All right, so now we're going to talk about Unit 3, which is databases. Now, this is a complicated unit, so this is probably a unit you're going to have questions for the Q&A session. So our objectives for this unit are to describe what a database is, the components of a database, and what a DBMS is, describe the purpose of databases and when to use them, explain relational databases and the entity relationship or ER model, be able to create an ER diagram given data. And for those of you who are choosing to do the database design homework, that's what we do with an ER diagram. You'll be describing the different DBMS operations and be able to explain what SQL is. So what exactly is a database? So a database is a self-describing collection of integrated records. And with the relational database, it's made up of a table. The table is made up of records or rows. Those records or rows are made up of columns or fields. And those fields or columns are made up of bytes or characters. Now, a non-relational database, they vary by type. Okay? The focus of this course is really on relational databases. So if we look on the right side of the slide, we have a table or file. The table has 3 columns: student number, student name, and final exam. There are 2 records or rows, the first one being 1, 2, 3, 4, 5, Jane Smith, and a final exam of 90. The second being 3, 4, 5, 6, 7, John Smith, with a final exam of 85. Within each one of those rows, we have bytes or characters. So for example, for the row with Jane Smith, we have 1 is a byte or a character, 2 is a byte or a character, 3, 4, 5, JANESMITH. Those are all bytes or characters. So let's talk about what exactly is a database. And here's a great example. At the top here, you can see we have columns or fields. And in this example, we have 5 different columns: student number, student name, exam, quiz, total. You can think of these are similar to the headings in an Excel file. You have rows or records. And here we have 3 examples. Each one of those records is made up of characters or bytes. Okay. So for student number, there are 5 characters for each one of these records. Relational databases have 3 types of components. They have metadata, they have tables, and they have the relationships between those tables. So let's start with metadata. What is it? So we have things like data types. And there's a few examples on this slide. So we can have an integer data type, okay? Abbreviated as int. This is a whole number, okay? 5, 15, 90, these are all integers. We could have a strings data type, abbreviated as varchar. And examples of these are dog, John Smith, Introduction to Information Technology. And if we look at the example below, we can see that there are 2 strings, the varchars, and 2 that are integers. Now we also have keys. And so in a database here, our metadata includes keys. And so we can see in this example down below, there are 2 keys defined. Advisor ID is the primary key. Okay? The primary key is a unique identifier per database table. We know that advisor ID is unique, so that would be our unique identifier. So we call that our primary key. The second one there where it says mul, that's a foreign key. Foreign keys are how we define our relationships. You'll see that in this example, it's student number. So for student number, that's a foreign key. We don't actually put the student number in the table with the advisor. That's a separate piece of data. It's a different theme of data. So we're going to put that student number in a separate table for a student. This will become clear when I show you some examples here later on. So let's look at this example here of what are relationships. We have an employee table at the top, a course table in the middle, and a student table at the bottom. Now, if this were a spreadsheet, all this information would be in one table. But as spreadsheets grow, they become more complex with multiple pieces of data in them. They're not the most effective way to store data in a database. So we break the employee information into an employee table. We break the course information into a course table, and then we have a student table with the student information. Now we can build relationships between the employee and the course. So for example, John Smith is a professor, and he teaches course 123, course ID 123, okay? Well, what is course 123? That course ID in the employee table is a foreign key, and it's pointing to the course ID column in the course table, okay? And we'll see that course ID 123 maps to Business 101 as the course name. Now, similarly to that, the student, okay? Student number 12345, which is Sally's student, is enrolled in course ID 123. Course ID 123 is a foreign key to the course table here and the course ID column. And we see that course ID 123 is Biz 101. So we can see that John Smith is the professor for Biz 101. Sally's student is a student in Biz 101, okay? Now, when we build a data model, we have entities and we have relationships. And when we build that model, it's called an entity relationship or ER data model. Entities are something to track. Teachers, students, employees, classes, okay? Attributes describe the characteristics of that entity. So an attribute might be for a student, student number, student first name, student last name, student phone number, okay? And then the identifier uniquely identifies an entity. This is our key, okay? So for a student table, it might be student ID. It's probably not going to be student name because we can have different students with the same name. So we have a unique identifier. Now with entity relationship diagrams, we have this concept of cardinality. And we use this to determine the number of relationships between two tables, okay? So if we look at this from the perspective of, say, a student and a class and a professor, okay? And we're gonna go back for a second and explain this after I explain what these mean, okay? Maximum cardinality is the maximum number of entities in a relationship. We symbolize this with what's called a vertical bar, and we do that for if there's a maximum of one entity in a relationship. If there are multiple entities, we use what's called a crowfoot. I'll show you an example of that in a few minutes. We also calculate the minimum cardinality. This is the minimum number of entities in a relationship. If the entity is optional, then we use an oval. If there's at least one entity required minimum, we use a vertical bar. Now let me show you an example, okay? So using this relationship, an employee has a minimum of being in one course. Okay. You have to have at least one employee teaching a course in order to offer the course. Now, generally speaking, you would have one professor running a course. So there's a minimum cardinality of 1, so we would use a straight up and down line to represent the relationship, okay? And because there's a maximum of one professor per course, then we'd use a second line to indicate the maximum is one professor in one relationship. For the student perspective, can a student be enrolled in more than one class? Yes. So we would depict that they can have a maximum of many classes. So we would use a crow's foot. And again, I'm going to show an example of this a little bit later. A student, in order to be enrolled, has to have at least one class. So we would use a single line to represent the minimum cardinality as one class per student. Okay. I will come back to that a little bit later. Now, database design. With a database design, we have tables, we have foreign keys, and we have metadata. So what we do is we convert our data model to a database design. And we do this through normalization, which is converting poorly structured tables into 2 or more tables. We construct tables with a single theme or entity. So student, professor, class, okay? And then our purpose to doing this is to minimize data integrity issues. So when we take a model and convert it to a design, our entities become a table, the entity identifier becomes a key, our entity attributes become the table columns, we use normalization, and then we build any relationships using foreign keys. We have 2 types of keys, as I mentioned. The primary is a unique identifier, student number, social security number, okay? Not date of birth, not name, not email address, because I know it seems kind of far-fetched to say email address is probably not a good foreign key or a primary key, but what if 2 people share the same email address? Okay, that could be a problem. So we come up with unique identifiers instead. And then the foreign key is the map that literally links 2 different tables together. Okay. Now, data integrity problems can lead to incorrect information, data inconsistencies, duplication of data. We lose confidence, and then the system gets a poor reputation. So then people stop using it, and then it's a vicious cycle. Okay. You can skip over the slide that talks about labs. We don't do those in this course. Okay. Purposes of databases, we use them to organize data and track data with different themes. So what exactly is a theme? Well, student grades, employee contact information, department information, student personal information, or the contents of the produce department. So when do we use databases? We use them when there's multiple themes of data. When do we use a spreadsheet? If it's a single theme of data. So when we have a database, what do we use to manage it? We use what's called a database management system. Okay. Oracle is not a database. Oracle is a database management system. We run databases on Oracle. SQL Server is not a database. It's a database management system. We run databases on SQL Server. Okay. DBMSs create databases, they process databases, and they administer databases. And so for DBMSs on the relational side, we have different types of licensing models. So we can have a commercial license where in order to even use the product, you have to pay for a commercial license. And so on that axis, we have Microsoft, SQL Server, and Oracle are the big players on that side. Then we have open source licenses. What this means is for certain purposes, you can use the database for free, but if you want support, you're going to pay for it. And so there are several options there. MariaDB, MySQL, PostgreSQL are some examples. As far as DBMS interfaces that are graphical, on macOS, we only have Table Plus, and it costs money. Okay? For you Windows users out there, you have HeidiSQL, which is a free option, and you also have Table Plus for Windows. Okay? Those are the DBMS interfaces that are graphical in format. What do we do with the DBMS? We can read data, we can insert data, we can modify data, and we can delete data. Okay? So how do we do this if we don't have a graphical tool? Well, we use something called SQL, or SQL, stands for Structured Query Language. It's an international standard. It's used by DBMSs. It's a critical skill to learn, and I've got a reference book that I highly recommend. And so for your students, you're going to click on the appropriate link on this page here. Okay. Now I'm going to show you some examples of a SQL database. Okay. SQL being used to manage a database, my bad. So this is an example of me creating records in a database using SQL. Okay. So I've got a database and I happen to have created it in MariaDB, which is a free database. It's a database called HR, and I'm going to go ahead and insert into the departments table. And I've got 2 columns, department ID and department name. And I'm going to go ahead and insert records into that database. The first one is department number 101, which is finance. The second one, 102, which is human resources, etc. When I'm done, it says, okay. 8 records created. Now, if I do a select from the departments, I can see here's the department IDs, here's the department names. Okay. And then on the right here, you can see some other examples of some other tables that I have in this database. Another example here is I want to do a query on a database. So I can use what's called a select statement. Select star, star means everything. So a wildcard, okay? Select everything from location, and then I output it here to my screen. And I can see that I have 2 locations for my company. US, Canada, San Diego, Vancouver, the street address, and the postal code. Okay. I do the same over here on the right pane. I've got select star from employee. I can see a list of all employees. Okay. And then select star from departments. And I think the last one is select star from job titles. Okay. Here's another SQL example for you. We can create a database. Here's the SQL to create a database named HR. I can create new users who have access to the database. I can give each user different access to the database. Okay. Here's another example. Here I can show the SQL that I use to create a table called towns. Okay. So it outputs the SQL that was used. Now, if I need to recreate this table, I don't have to guess. I can just copy and paste this and boom. Okay. I've got a new table exactly the same way. Another example here, actually this is a duplicate of doing select statements. Okay. You can ignore the lab option in the slides. Now, non-relational databases, we have different types. We have document databases, MongoDB, Apache, CouchDB. We have key value, Memcache, Redis. We have graph databases, and we have column databases like Cassandra. Okay. We won't get into these in this class, but if you're interested, you can Google those names. Okay. We won't be doing anything with MongoDB in this class, so you can skip over this slide that talks about labs. All right. So what I'm going to do is I'm going to post all of these recordings, and then I will also post a demonstration in the syllabus for how to do the relational diagrams.